And then the proof of AI work protocol is all about providing a coordination layer for AI agents. And in our case, the AI agents are running fully on chain. And that whole coordination layer is also running fully on chain. So we indeed started working and we released it at the end of June, a gamified implementation of the proof of AI work protocol. And it's called funnAI. It's an application where AI agents are given challenges, and challenges are generated by yet another AI agent, an LLM that runs on chain. So it's a challenge generator LLM. There's a protocol, canister, that organizes everything, that coordinates everything. So that's really the proof of AI work in action. It coordinates sending the challenges to all the AI agents. The AI agents solve the challenge, they give a response back, and then we have yet another on-chain LLM that's also coordinated by the centralized controller canister. It's a judge that will then evaluate the responses that are generated. And then the fun thing is all these responses, they are then scored, and the best ones will be given a reward.
Welcome back, guys. Today I'm here with Arjaan, the CTO of Onicai, a leading company in the decentralized AI sector, leveraging the ICP technology. And I've already interviewed Arjaan some months ago, and today we're here to discuss about some progresses regarding Onicai, as they developed some very interesting features around the concept of proof of AI work and other features that Arjaan is going to present. So very excited to be here with you, Arjaan. Thanks for being here. And yeah, it would be great if you can introduce yourself and talk a little bit about what's Onicai and the latest progresses that you achieved, especially regarding the proof of AI work protocol. Yeah.
Yeah, absolutely. Yeah, thanks, Federico, for inviting me again for another chat. I enjoyed it last time. So, and you just said it was in March, right? So several months have passed. So yeah, a lot happened. But for those who didn't see the previous one, let me introduce myself a little bit. So my name is Arjaan. I've been a developer my whole life, basically. And I discovered the internet computer a few months after Genesis, and I was yeah, really intrigued by what it offered. So I also come from the world of AI, conversational AI. Even before LLMs existed, I was already working in that space. So discovering the internet computer, its capabilities, its unique features, and then coming from the kind of the Web 2 space of conversational AI, I saw a real opportunity and potential of trying to merge these two worlds. And yeah, I spent a lot of time exploring, figuring it out. And then I partnered up with Patrick Friedrich, who also was looking into running AI on the internet computer, and we founded Onicai. And Onicai, that name comes from on internet computer AI. So that's really our mission is in our name.
That's great. Thank you very much, Arjaan. And I remember during the last interview, we spoke about on-chain AI, basically running AI in a ICP canister. We also spoke about decentralized AI. Regarding running AI locally. So it's another way of decentralizing AI.
Yeah.
And at the time, in March, I believe, you were working on the proof of AI work protocol. It was still a concept, but now you basically deployed the first implementation of this protocol. So I'm very curious to hear from you about the progress in this field and what you accomplished and what you deployed in these terms.
Yeah, great. Yeah, it's such a fast-moving field, And indeed, when we talked in March, I would say we were right at the tipping point from doing all the exploration and kind of fundamental work to make sure things work to actually formulating the protocol. So we did write down what the proof of AI work, the POAIW protocol should do. And then we did receive a grant from the Definity Foundation to do an actual implementation of that protocol running fully on the internet computer. So that, and when I say fully, I mean fully. So we had proven that we can run LLMs in the so-called canisters of the internet computer. We had also proven that we can have these canisters be controlled by other canisters and basically create fully on-chain AI agents. And then the proof of AI work protocol is all about providing a coordination layer for AI agents. And in our case, the AI agents are running fully on-chain. And that whole coordination layer is also running fully on-chain. So we indeed started working, and we released at the end of June a gamified implementation of the proof of AI work protocol, and it's called funnAI. So you can go check it out at funnai.onicai.com. And yeah, it's an application where AI agents are given challenges, and these challenges are generated by yet another AI agent, an LLM that runs on-chain. So it's a challenge generator LLM. There's a protocol canister that organizes everything, that coordinates everything. So that's really the proof of the AI work in action. It coordinates sending the challenges to all the AI agents. The AI agents solve the challenge. They give a response back. And then we have yet another on-chain LLM that's also coordinated by the centralized controller canister. It's a judge that will then evaluate the responses that are generated. And then the fun thing is all these responses, they are then scored, and the best ones will be given a reward. And the reward is, of course, a minted token, because yeah, we're in the blockchain world. And I think that's the really unique thing about being able to build on the internet computer, is that you can build these type of really advanced, complex applications. I mean, we're literally running LLMs on the internet computer, but because it is on the internet computer, you can very easily just create a token and tie the work and the results to a reward mechanism through a token. So there is a token called funnAI. It's fully tradable. You can find it. So yeah, we released it in end of June. So we're coming up on 3 months in operations with that implementation of the protocol.
Very cool. And correct me if I'm wrong. So basically, your implementation of a proof of AI work is basically a way of coordinating and judging the work of many AI agents to check if everything and every AI agent is actually working as expected. And so is also a decentralized way to judge if the work is done properly.
Yeah, that's correct. So because that's a nice thing about the doing things on the internet computer, is that there's ownership attached to these canisters. So when somebody logs into, in this case, a funnAI application, they get a principal ID assigned, and that's their identifier. It's anonymous. The application really doesn't know who it is, but there's a unique identifier, the principal. And the first thing that was done is the logged in user creates what we call a miner, MAIN miner, which is just a canister, and that runs the LLM. And the principal is logged in owns that canister. So that's one aspect of the proof of AI work, is that the whole proof is there, that the protocol knows that the work was done by that canister. It knows who owns that canister, and then it knows if that canister did a good job, and it deserves a reward. It can mint the funnAI and hands over that reward to the owner of the canister. So yeah, that's in a nutshell the verification, proof, and reward mechanisms of the proof of AI work protocol. And of course, this is a gamified application. So we often get the question, well, how useful is the AI work? And in this case, it's actually pretty impressive what the LLMs can do. It's a pretty powerful LLM that runs fully on chain. It solves challenges that are pretty decent. But is it a really useful AI workload? I would say no, it's not. It's useful in the context of of funnAI and being able to have this application running and give out reward and mint a token and do that. But when you start looking at the future and doing useful AI workloads that companies do today, the same mechanisms of coordinating AI agents it is there, right? So it's a matter of having more powerful AI agents. The internet computer canisters become more and more powerful. The LLMs become more and more powerful. So we see a future for actually using the on-chain LLMs themselves for doing more useful work in this protocol. And then in addition, it's totally possible to offload the actual inference engine to hardware that you own yourself. It's possible to do the inference maybe in the browser, which we have also already proven how to do that. And it's also possible to run the inference engine off-chain, either in a trusted execution environment in a traditional cloud, or even go through a canister that's controlled by the protocol to a central service provider for the inference. So that's how fully state-of-the-art inference engines can be easily integrated into this protocol that's already up and running. And that's kind of where we're heading with the expansion of our capabilities.
Right. Yeah, and also because we must remind that it's everything very new. So basically, you're pioneers in this field, and the proof of AI work concept didn't even exist just a few months ago. Now we have a first implementation, and you're basically giving something new to the people to experiment and work on. And yeah, just time is going to tell us what's going to be possible to do with that and how useful it will be. So congratulations on your achievement. This is really great for the entire ICP ecosystem and for the decentralized AI ecosystem as well. And yeah, I also wanted to ask you if you could talk a bit about the Llama model that you deployed on ICP, because you created the Llama CPP canister to open up this decentralized version of the Llama LLM to the public. So yeah, if you can talk a bit about that and how users can use it and what are the advantages related to the solution.
Yeah, absolutely. Yeah, thanks for asking that one. I did spend a lot of time on getting Llama CPP to run on in a canister. It was really fun. I mean, if you're in the if you're in the world of looking deeply at how LLMs work and the different frameworks, then mostly people will be familiar with llama.cpp, which is an open source framework that was developed by Gergenov. It's an amazing C++ program. It really is very impressive. One of the unique things about the Internet Computer is that it runs WebAssembly, and any software, doesn't matter what language is written in, can be Fortran even. If it's Fortran, C++, Rust, Python, TypeScript, or Motoko, that's the native language of Internet Computer. It doesn't matter. As long as you can compile it into WebAssembly, it can run on the Internet Computer in a canister. And so that was a challenge I took on, is say, well, okay, I wrote the C++ CDK, canister development kit, so I knew how to compile C++ into WebAssembly that runs on the Internet Computer. And one of the challenges I took on was, well, let's try to run llama.cpp, just this open source C++ framework, to run in a canister. Because if you can do that, you can run any LLM model in a canister, because that's what Llama CPP provides. It's a framework, an inference engine framework that can run any type of LLM and do inference on it. And it can be the Llama, the Llama 2, Llama 3, the Qwen 2 models, you name it. Any model can be uploaded and then run with it. So yeah, we managed to get that running. We pushed the limits for what the canister can do. We even were able to run the DeepSeek 1.5 billion parameter model in a canister. That could generate only one token per call. So it was not usable in that sense that you can really use it for applications, but it was possible to run the DeepSeek model in a canister. We dialed it back a little bit for the application in funnAI. So inside funnAI, the miners and the judge and the challenge generator, they all run a Llama CPP application in a canister. And the model that they're running is a 650 million parameter model. It's the Qwen 2.5 model. And yeah, it's open source. So if people go to the Onicai GitHub repository, they will find llama_cpp_canister, and there's actually a release available where you can just download the WebAssembly of the Llama CPP canister and some scripts, and then it's pretty easy to just deploy it and get your own Llama CPP running in the canister, and then do things with that.
Right. I will leave the link in the description so people can check it out. Yeah, that's great. And yeah, I wanted to ask you, in your opinion, what's the advantage to run a LLM on chain?
The biggest advantage of running an LLM on chain is it's really the ease of deploying and managing and controlling it. I mean, if it can run in a canister, it's just a smart contract. And smart contracts on the Internet Computer are so easy to deploy and to manage and to control and secure. It's super, super simple. And that's why you see so many nice applications on the Internet Computer that are built around these smart contracts. And these canisters can interact with each other, and you can call it. And it's just very easy to compose applications from canisters. So if your LLM is just a smart contract, it's very easy to compose it into other applications. So that's why for funnAI, which is our first implementation of the proof of AI work protocol, we chose to just go with an on-chain LLM, which is just a smart contract. It's just one of the canisters that participates in the whole application. And it's being called and managed, and just like any other canister, any other smart contract. To me, that's really the biggest benefit of just running an LLM on chain and be done with it.
Right.
So yeah, that's you can extend it and say, well, now you can run LLMs and fully secure and private. But everything that you say about why do you want to run an application as a smart contract can be applied to that reasoning of why do you want to run an LLM as a smart contract in a canister.
Right. Thank you. Thank you very much, Arjaan, for sharing your view on this. And since you're a AI expert and also a ICP expert, I wanted to ask you, now we have Caffeine AI, which is one of the most important applications now running on the internet computer. And so I wanted to ask you, what do you think is going to be the impact of Caffeine AI on cycles burning, on the ICP adoption, and future price increases of ICP?
Yeah, yeah, yeah. I hope it's going to be huge. I did play with Caffeine AI myself. It's very nice. It's really impressive how the caffeine development team wrapped the application development for internet computer applications into this very, very nice environment where you just log in and you start building and it deploys it and you can iterate through it. So it makes it extremely easy to for non-developers to yeah, to bring their ideas about things they want to build and make a reality out of it, and it runs on the internet computer. And it's deployed, it's production ready, you can iterate to it. It's very, very nice. So yeah, I hope that it really will take off and will reach a lot of people that start building. I think the main the main use cases I see for Caffeine AI is really that people that want to build applications and want to build applications that are tied to some kind of a reward mechanism, right? I mean, that's the whole point to me of blockchain and crypto and building on blockchain, is that it's so easy to connect it to reward mechanisms, verification mechanisms, just like what we do with funnAI. But funnAI is a very complex application. But there are so many applications that are how do I say that they're simpler in architecture than what something like funnAI is. But they have mechanisms where you want to share it easily, you want to maybe reward people for contributing to it. And those things are very hard to do in a Web 2 environment. I know there are applications kind of like Caffeine AI for building websites on Web 2. But what those applications really will struggle with is to allow the creators to monetize their applications. And if you build something and you want to have others contribute to it, or you want to kind of build up some little economy around it, those things will be natural for applications that you build with Caffeine AI because you build it within blockchain environment. So yeah, that's where I see really the potential explosion of use cases, Caffeine AI, and of course, since it runs on the internet computer, that drives canister growth and drives cycles being burned, and that's the core tokenomics of the internet computer, is that the cycle burn. You can only get cycles by buying them with ICP. And that's the whole supply and demand equation that then will go in the right direction. So we maybe another good reference is how Caffeine nicely ties into other projects and how easy it is to do is funnAI was released, and at the same time, the alpha release of Caffeine AI came out. Some of the developers and people and non-developers in the ICP ecosystem, they were given access codes. So we saw some early results of it, and then we put out a challenge for funnAI and say, hey, if you build an application with Caffeine AI that ties in, sorry, with Caffeine AI, right? That ties into funnAI. It could be anything. Could be take the logo and make a game with it, or tie it into some of the APIs that are exposed by the funnAI canisters, and then build applications with that. Doesn't matter what it is. And even though only relatively few members of the community had received access codes to Caffeine AI, we already got a lot of very nice examples. So I see this network effect. I mean, that's another thing where I think crypto in general, blockchain in general, and also ICP in particular is really strong. It's this network effect where people want to help each other and they want to build on top of other applications. And the way the ICP is architected is it's just designed for that. It's designed to create canisters that are smart contracts, and these smart contracts have endpoints. They are openly available. So we didn't even have to put out an API spec of what our canisters do. No, it's just known. You just go to a dashboard and you look at the canister and you see the endpoints. And many developers, they just figure it out and they build really nice applications with Caffeine AI to show some of the fun with some of the funnAI tokenomics, some of the key aspects. So I see there also a real potential for Caffeine AI to get this network effect going. You just don't have that in Web 2. I think if you look at something like Lovable, for example, I don't think you have a network effect there where one developer is building on top of another developer's capabilities. It's much more isolated, everybody for their own. And I think with Caffeine AI, you're going to get much more interactions and building on top of other other capabilities that other projects have built, and we actively encourage and promote that type of use of Caffeine AI.
Right. Yeah, and probably also because with Web3, as you were saying, there's also the economic incentive, right? So,
Yeah.
so it's just one more thing that pushes for a network
Yeah.
effect and collaboration and gives more incentive, right?
Yeah. So one of the applications that somebody built as part of the challenge was to build a staking application where you start with funnAI, but then you stake it and then you can earn some rewards and you can create another token that kind of builds on top of it. So those things are just impossible. Web 2, you just can't do it. And first of all, it's a lot of fun to do that. And secondly, you can just make some earnings with it.
That's
just
right.
great. Yeah.
Yeah. And yeah, also, I'm very curious, Arjaan, what are you working on right now, and what are your plans for this and the next year? So if you can share with us like a short-term roadmap and also a long-term roadmap.
Yeah. Short term, we did receive a follow-up grant from the Definity Foundation to execute on kind of the second phase of the funnAI application. So the first grant was develop the core capability of the proof of AI work protocol and deploy it and get user traction. So that was accomplished. And now the second phase is to build out additional capabilities. So for example, just this week, we released several capabilities. We did release an API canister, the index canister, the dashboard was enhanced, We have new settings for the miner. You can set it to run at certain, let's call it speeds, like low, medium, high. You can just add another level there. So we're very focused between now and the end of the year to execute on implementing the milestones of that second grant that we received. And they're focused on the focus really is on expanding the capabilities and get new type of a miner. It's a power miner that has its own LLM. And another one that's going to be really important is a marketplace for the miners, because there is a limit to the number of miners that will be released as part of the protocol. We set it at 990. And we want to enable that owners of those miners can actually put it up for sale, or just send it to somebody, or actually sell it. So that marketplace will be developed and become available. So on top of that, more longer term, we want to make it a reality that you can truly coordinate AI agents that are doing AI workloads. So we did write a white paper for funnAI, and we kind of spell it out in there, how we see this evolve. And over the next few months, we're going to kind of start work on that. And then next year, we see to really start working on that capability to expand what you can do today with funnAI and build it out into full-blown coordination layer for AI agents, where the inference engine can either run fully on chain as it does today, or in any other environments that are available. And as I mentioned, it can be in browser, use the GPU of your local machine easily, or it can be some kind of a powerful GPU that you own, so it runs on your own hardware, or it can be in a trusted execution environment of a traditional cloud provider, or it can just go through a canister to a centralized API. But the coordination of those agents will be done then through the proof of AI work protocol. And when we talk to people about this concept, it is recognized as a valuable thing to do, because one of the things that AI agents struggle with today is exactly that coordination aspect. So one AI agent cannot do everything. And these AI agents, when you give them very complex tasks, they do tend to get lost after a while, and you have to go. They need a lot of guidance. Let's put it that way. So the concept of almost like compartmentalizing these AI agents and having be more dedicated to a certain task, but then be able to easily spin them up, maybe automatically spin them up as part of your the problem that you're solving, and then be able to coordinate or chain them. I think that's going to be very, very valuable. And the ability to just spin up an AI agent, that's already there. I mean, we do that as part of the funnAI application, right? If somebody says, I want to get a miner, it literally just spins up an AI agent right there on the spot. So that capability is already there.
Right. Yeah, that's great, because it's something that it's helping not only the Web3 space, but it's going beyond that. So
Yeah.
that's
And
great.
we're gonna dog food it ourselves. So I mean, for our operations, we use AI workloads ourselves quite a bit, right? For communication, for image generation, there's a lot of things. If you think about it, that you use AI for that, it can be written up as an AI workflow. So if you can automate that, and then maybe you have to split it up across several AI agents. I mean, if you look at how you use AI yourself, how I do it myself, I very often go to 2 or 3 different AI environments to get something done. But if you can formalize that and say, well, I do this in that sequence, I think those are great use cases to be plugged into the proof of AI work protocol. And I can see projects of organizations that need that type of repeatable AI work done that can be nicely then plugged into the proof of AI work protocol. And then payments, rewards, and all those things they come natural. They don't have to be done via a difficult contract. It can just be programmed in as it is. So
Right. Yeah,
those are some of the use cases that we're going to use ourselves. Yeah.
that's nice. Yeah, yeah. It's the best. I often talk to developers and they find out some problems in the process of how they are working, and then they see, okay, so yeah, let's build a solution for that, and then they
Yeah.
open it up to other users, and
Mm-hmm.
that's the best way to build, because it means that there is a real problem there, and the solution is actually really useful and effective.
Yeah.
So thank you very much, Arjaan. It was a great talk. It was very nice to hear your progress, and also your roadmap. And is there anything else you want to share with the community?
No, the main thing is, yeah, I just want to again thanks everybody for being there with us. Yeah, we are a development team and of some of the capabilities, and we get a lot of feedback. So we're on open chat. If you're interested in what we're doing, I recommend that you just join our open chat community and yeah, share your thoughts there and join the conversation. And we're very open, very interested to hear what people think. And we're talking more and more to people about next steps, like how we're gonna build this out. And if anybody has examples of use cases of how they use AI today and how they would like to use it, maybe in a more automated manner or a more controlled manner, or more putting in some of these mechanisms of verification and proof and reward mechanisms. Yeah, please share it with us. It's much
Thank you.
appreciated.
Thank you very much, Ariane. And guys, so if you liked this episode, don't forget to like, subscribe. I will leave the links to Onikai in the description, and see you in the next episode. Thank you, Ariane.
Thank you.